Oh, thank you so much for, for all the effort you put into being here today. It's great to see, new faces. My name is Milena Oliveira. I am the Extension Vegetable Specialist for Utah State University. So together with Mike Pace, Mike, Mike is there. So Mike is helping me to put this meeting together. So you might have received some emails from him. So thank you, Mike, for helping with that. A short introduction about myself, since I'm still pretty brand new to the university. So I was born and raised in the northern part of Brazil, which is pretty much dry, like here. So semi-arid region. I have been working with fruits, vegetables, ornamentals since my bachelor's. I did a lot of work with melons, watermelons, cantaloupes, all kinds of peppers, tomatoes, and so on. So today we are hosting the second vegetable grower meeting, and that is actually one of the needs that showed up in my needs assessment when I started. So we put this meeting together for you guys. So it's better to serve the vegetable growers in Utah. Second talk will be Suresh, and just bear with me because we have to test. Hi, Suresh, are you there? So Suresh it's myself, but in Connecticut. So he's a extension vegetable specialist in the University of Connecticut. He's gonna talk about biodegradable plastic mulches. We always get a lot of questions regarding, this topic. So I invited him to give this talk. Let's test the audio first. Suresh?
Sure. Can you hear me?
Yeah, very loud.
Okay. Reduce the voice, I guess.
Yeah, it's
Volume.
great. Yeah, go ahead. Yeah, share your presentation.
Okay. I will replace the current presentation there and then share this window. Let's see.
Yep, I think you got it. Just share. Yeah. Thank you, Mair. Thanks so much. Yeah. It's working. Thank you.
So are you seeing the presenter view or the good view?
Suresh is great. You can go ahead.
Awesome. Yeah, first off, thanks for the opportunity to present. I am Suresh Kimire, Vegetable Extension Specialist with University of Connecticut. And as you see on the title, my focus of talk today will be about plastic mulches and should you make the switch from polyethylene mulch to BDM, biodegradable plastic mulch. In short, I'll refer it as BDM. And I will talk about how they're made, their performance on crop yield and quality, any impact on soil quality. I'll also touch on economics. We've got about 25 minutes to talk, so let's see what we can get. Before I jump in, can I ask you? I see some of you, maybe a person of you there, two lines. Can you raise your hand if you use plastic mulch? Okay, I see like 5 or 6 hands up. And then can you raise your hand if you use biodegradable plastic mulch? 1, 2. Okay, that's great. So looks like some of the information I am going to present will be relevant to you guys. So um, as some of you may already know, plastic mulch is mainly used for weed suppression. It also moderates temperature, soil and canopy temperature, and it increases crop yield and quality. Currently, most of the plastic molds that is used in crop production system is non-biodegradable polyethylene molds. And there are some real issues, environmental and economic issues related to the use of polyethylene mulch, and I'll highlight some here. Um, when you remove the PE mulch, it takes some topsoil, estimated about 1,000 pounds of topsoil per acre. It doesn't seem to be a significant amount of soils in the grand scheme of things, but if you're removing that every single year, that's the topsoil, most fertile soil with high organic matter. It is something. And complete removal is practically impossible, and remaining fragments can pollute soil and surrounding environment. I'll talk about some reports that talk more about that. And removal and disposal is costly, and because it is not biodegradable, you can't till it in. And these are some reports. There is no reports from US that is looking at uh, plastic contamination in agriculture systems. I'll present some reports from China and other European countries. They have been using plastic polyethylene molds for decades now. And in some reports, as I'm highlighting here, they're finding over 40,000 pieces of plastic in kilogram, about 2.2 pounds of soil here. And on this report, you see river pollution in China from crop production and urbanization, and here agriculture plastic films contribute 20% to the plastics in Chinese river. So they are ultimately going down to rivers. And these reports highlight a vast majority of 39% of the plastic contamination in agriculture soil is because of plastic mulch here. And regarding their impact on crop yield, in a field where they continuously use PE mulch over 20 years, um, they reduce the crop yield by 19%, which is significant. Again, these are reports from China and southern Spain, where they've been using plastic molds for decades, and they are now starting to see problems associated with the plastic contamination. Here in the US, we are newer than those areas in terms of use of plastic molds, and we don't want to get where they have reached now. So, what's the alternative? Soil biodegradable plastic molds, BDM, could be alternative or better alternative to polyethylene mulch. They are engineered to biodegrade in soil. Once they are incorporated, they are manufactured with different feedstocks compared to PE molds. And to be labeled as biodegradable, they should go through testings and standards. They have to pass the standards. Specifically, they should biodegrade at least 90% in 2 years, and that is so far tested in laboratory, but using soils. And so these are some standards, and I will touch on some of these. EN 17033 is the first international standard pertaining to biodegradable plastic molds. UNI 11495 is Italian standard. ASTM D6400, that is uh, industrial composting standard for biodegradable plastics. And OK Biodegradable Soil, that is through TUV Austria, it certifies if the plastic material will biodegrade fully in soil. There are OK biodegradable soil, OK biodegradable industrial composting, OK biodegradable home composting labels, and they respectively certify that the material will biodegrade in each situation. If it says soil at the end, it will biodegrade in soil condition. And these standards will be relevant when I talk about the products available in the US later in the slide. One thing to note, is oxo and photodegradable plastic molds. And a lot of bad experience our farmers have had in the past, especially in like late 90s and early 2000s, were from these materials. They were marketed as biodegradable, even though they were not biodegradable, totally different things, but they were marketed as biodegradable, and some farmers had negative experience with those products. And because of that, a lot of farmers that I talked to um, have shared in the past, like, I heard about these products and didn't do well like 25 years ago and things like that. So I just want to set some lights on what these materials are and where we are with them right now. So oxo and photodegradable plastics are made with conventional plastics like polyethylene, but includes to additives in between. So what happens is when they degrade, they fragment. The additives will be made out of like stars or degradable material. So additives would be degraded, but the entire polymer will not be degraded. They will just fragment into pieces and they will stay there for a long time. EU prohibits single-use plastic products made from oxo-degradable um, plastic. That was now a long time ago, but in the US, there's still not a good regulation about use of those. And on the picture you see was taken after 3 years of use of oxo-degradable products. It looks pretty new, even after 3 years. Another thing to highlight here is biodegradable plastic molds were added to the list of allowed substances for organic agriculture in the US. So technically they are allowed, but the criteria are such none of the products available in the market meet all these criteria. So therefore they cannot be used in certified organic. So these are the criteria. They must be 100% bio-based. They must be produced without GMOs or without GMO in the processing as well, like to increase the efficiency of processing to manufacture, um, let's say, polylactic acids from sugar. They use genetically modified bacteria, yeast, and that is not allowed in organic system. And these last two criteria meet compostability specification according to one of these standards or reach at least 90% biodegradation within 2 years. A lot of materials meet those two standards, but they don't meet, none of the products available in the marketplace meet first two standards. That's why they are not allowed. There is a paper product, mulch, for example, Weed Guard Plus, that is allowed. Again, it's a paper of totally different properties, but it is allowed in organic systems. So I'll switch gear here and talk about impact of these biodegradable plastic mulches on crop production. Um, and just want to highlight one meta-analysis study here that summarized all the papers published up until the publication of this study was 2020. And here is the a little background. So when you see plus on this first, I mean, anywhere, plus means BDM perform better than whatever is on the top here, bare ground. BDM perform equal to PE. If you see minus, BDM performed poor compared to whatever is on the top. So what you see here is the crops, broccoli, cucumber, eggplants, a variety of other vegetable and small fruit crop, and lots of pluses. So that means BDM performed better than bare ground, which is very expected for these crops in terms of yield. Here you see lots of equals, some pluses, and some minus. So mostly they are comparable, but with some variability here and there. And then for weed control, it is mostly equal, and in some cases there is minus. So that's the summary of literature regarding BDMs. And what happens to BDMs after you till it in? They are tilled after harvest so that there is no um, removal or disposal, saving labor. The plastic films will fragment and break apart. The process of biodegradation is first fragmentation. They will turn into microplastics and nanoplastics, but ultimately they will be consumed by microbes and they will biodegrade. So, but the process is um, process involves fragmentation and formation of micro and nanoplastics. Something to understand there. And this is a graph where this shows mulch recovery after incorporation. This was done in Western Washington while I was a graduate student, and I continued this work after coming to this position at UConn. What you see on the x-axis here is the timeline, and the y-axis is mulch recovery. What percent of mulch that was put in was recovered. So we applied and incorporated plastic mulch from 2015 spring, 2016, 17, and 18, 4 consecutive years. It was incorporated twice, in once in the fall after crop harvest and once in the spring for land preparation. And we started tracking the amount of fragments, visible mulch fragments, starting 2016. And at the end of after 2 years of final incorporation, so fall 2020, mulch recovery was 12 to 16% after 4 consecutive applications. So this suggests that the mulch were degrading um, over time. And the climate of that research site was mild summer and mild winter. Uh, And we plotted that against the thermal time. Here is the calendar time. This is using the real data, collected data, and how much would it take to 100% biodegrade and 90% biodegrade in that climate. And based on the previous graph, just utilizing the data from previous graph, it would take somewhere between 2 years for, uh, or I mean, nature cycle to over 5 years for organics in Western Washington when the overall climate is cold. But when we plotted that against the thermal time, and assuming this line is for the thermal time equivalent to where they do the testing, like 24 degrees Celsius to 48, I mean 28 degrees Celsius, that's where the test happened. If the temperature was 26 degrees Celsius, um, most of these products, except for this one, would have biodegraded within 2 years equivalent of thermal time. Does it make sense? If the temperature was equivalent to the lab temperature where they would do the testing, all these products would have biodegraded 90% or 100% within the 2 years. It took longer, 2 to 5 years, because the climate was cold. And again, we plotted this graph, again, based on the thermal versus calendar time. If the temperature, like here, these are different lab tests. Again, I said 24 to 48 degrees. It would take, if it takes 2 years to biodegrade at that temperature in Quincy, Florida, it would take a little bit more than 2 years because they don't achieve the same level of temperatures. In Watsonville, California, it would take um, about 3 years from 2015 to 2018 to be like this line is 90% biodegradation. And in colder climate like Mount Vernon, Washington, Western Washington, it would take 45 months to biodegrade. So depending on the climatic condition, the degradation timeline varies. And this is really interesting graph where this is again plastic accumulation in soil, and we have 100%, I mean 0% biodegradable, which is non-biodegradable conventional PE. Three hypothetical scenario where BDM A, B, C have degradation rate of 10, 20, and 50. This is all hypothetical. And what it demonstrates is even if BDM is 10% biodegradable, if it biodegrades only 10% in year one, 10% in year two, and so on, it will not accumulate um, indefinitely. It will accumulate for some times, and starting 6 to 8 years, it would start plateau. This is 10%. This is 20%, and this is 50% degradation. Obviously, it's a pretty flat line. So even though a mulch, if it is only 10% biodegradable, it's not gonna keep accumulating over time like PE does. So it's gonna plateau at some point. And obviously, PE is not meant to be tilled, but again, as we highlighted, even if you try to remove it, about 10% remains in the soil. And now, what is the impact of these mulches on soils? Um, so again, think about the last graph. There is accumulation up until certain years, and then it plateaus. And this paper evaluated the literature on degradation and ecotoxicity of biodegradable material, and they suggested here, I want to highlight here, uh, it would form microplastic and nanoplastic along the way, but would not accumulate substantially in the environment and would be far from reaching concentration at which negative impacts on ecosystems can be expected. So there will be some amount of nanoparticles, microplastic particles of those biodegradable plastic, but it's not gonna negatively impact the ecosystem. That's what their conclusion is. And here is a breakdown. If mulch is 10% biodegradable, 10% biodegradable in 1 year, the accumulation would be maximum accumulation would be 0.043% weight by weight. And that is not enough to do any negative impact on crop and soils as reported by the other reports here. The negative impact would be seen when there would be 0.1% accumulation for corn, 1% for wheat, and 4.5% for tomato and lettuce. So this is far beyond the amount that is negatively impacting. So there are many other reports. I want to highlight some here. This one says there was no negative impact, but there were some positive impacts. Biodegradable mulch increased soil microbial, soil ureas, and soil catalysis activities compared to those for polyethylene mulch. And BDM can reduce soil bulk density, and long-term use of BDM can cause a decrease in um, does not cause in decrease in soil nutrient content and microbial activity. Um, yeah, I will want to present this graph, and this is like 2 to 3 years of mulch accumulation. This is no mulch, polyethylene mulch, and biodegradable mulch. And on the y-axis, you see overall soil health index. That is combination of all soil physical, biological, and chemical properties. Zero would be the absolutely worst soil, and one would be the highest quality soil. And as you can see, after 2 to 3 years of mulch application, there is no negative impact due to BDM, but perhaps some positive impact on soil quality. Um, do I have a few more minutes?
Yeah, you do. Go ahead.
Okay. So, talking about the price, the purchase price for BDMs is still higher than PE mulches, but that's not the complete picture. If you consider removal and disposal cost, it can be sometimes, depending on your labor rates, it can be cheaper. And I'll break that down quickly as well. So in this hypothetical scenario, using BDEM, farmers would save $88 per acre, actually saved, even though it costs more. And I'll do these sensitivity analysis. And this is keeping everything else constant and changing just one variable. In this case, they are changing the variable, the cost is the variable of BDM. If BDM per roll cost less than more than 365, there would be loss. But if it costs less than 359, there would be profit. So again, lower the cost, the profit would be higher, and higher the cost, the loss would be higher. And here is the labor hours. Um, if you can remove and dispose of the PE molds in less than 12 hours per acre basis, then it would not be economically beneficial to use BDM because you are not spending much labor to deal with PE, but that's not the case. It takes much more hours than that. And this is the adverse effect ways. H2A labor rate in Utah, it is $17.84. And if the labor rate was less than 11.6, which is not the case, BDM would not be profitable. Cheap labor to remove the PE, but that's not the case. As the labor rate is higher than that, close to this, BDMs are profitable. I have two tables. I don't want to spend time talking about them, but we put together a fact sheet with the commercially available BDMs in the US, who you can buy from, what are the materials, what are the certification, so to make you informed decision about if those products have gone through standards or testing. And I have two tables here, and the fact sheet is available through this link. So you can, I think this will be the presentation will be available, so you can look up later as well. And to wrap up, I'd like to play a video, about 2.5 minute video, if we have time, from a Connecticut grower sharing his experience of using BDM, like switching from PE to BDM. And that will be the second last slide.
We are always willing to try new things. I think that's important. Through all the years I've been here, we've always been willing to try something that's a little different than what we're used to. My name is Steve Bankson. This is Cold Springbrook Farm. We're in Berlin, Connecticut. This is a family farm. It's been here in our family since 1910. Changed a lot over the years. Right now it's vegetables and also greenhouse business. We do use biodegradable transplanted sweet corn, eggplant, summer squash, some greens. We started about 5 years ago. The place that we get our supplies from started advertising some of these different biodegradable plastics. We just took one roll and tried it, and we liked the response we got from it. And we've been increasing every year, doing a little bit more. I see very little difference in the price of the regular poly film in regards to biodegradable. We probably use 10 rolls of the biodegradable film this year, and we would normally be using 20 rolls of the regular poly. At the end of the year, we're not paying for the labor at all. That really helps. We do not use it on tomatoes except for this, where we're trying it for the first time, concerned that the plastic might stick to the fruit. We're open to trying new ones as they come along, and that's why we're doing this right here with the tomatoes and see how that manages.
And I can confirm that it did not stick to tomatoes. So
we are always willing to try new things. I think that's.
I mean, it went back, I guess.
And see how that manages. we like the idea of it really making our life easier. That's the main thing. You want to have a good crop. You want it to be best crop you can grow. You don't want to have blemishes or problems with your fruit, and you want it to save you some labor. And that's what makes us go back to it. Plastic goes down at the same rate that the regular plastic goes down at. It doesn't slow us down or hamper us in any way. We found that once you get used to using it, we can just drop the machine and go just like the other plastic. If you find that it's acting up a little, like it might be trying to grip it, or if it's a little too tight, you make an adjustment to loosen it on the rollers. When you let those rollers stay tight, it keeps tension on the plastic, and this plastic doesn't like that. So it has to go down a little bit loose. It still gets down, it gets covered over, and it works, but it's not as tight as you would use like for embossed plastic.
Getting cover crop in time is another great benefit of using biodegradable plastic molds. You can just till it in and have your cover crop planted.
One of the biggest things is cleanup at the end of the year. It's always a time when you're exhausted and you just want to be done farming, and we'd have to go out, mow all the crops down, and then loosen the edges of the plastic and pull it all up. A lot of times it's wet and there's weeds all over the place and you can't get it up. So being biodegradable, you just have to get the drip line out of there and harrow it in. I would definitely recommend that people try it. Try it on your farm and try it with different crops. That's how we did it, and we found that we were happy with it. I think you'll find that it's worth trying it.
Okay, that was the video. And to conclude, so far we've seen BDM perform equivalent to standard PE mulch. It's not going to negatively impact soil health. Connecticut growers and a lot of growers in the Northeast use it for economic reasons, even though they care for environment. The main driving factor is economically makes sense to use BDMs, and it's a viable alternative. And that's my contact info if you'd like to follow up with anything. But if in the meantime, if we have a couple of minutes, I'm happy to take any questions.
Yeah, thank you, Suresh. Do you have any questions? Sure. Yeah, you can speak from there. So
In traditional polyethylene chlorine is sometimes used in its production, and then something like that produce polyalcohols, which the government is currently cutting down. There's 111 farms in Maine that are now shut down for production because they use sewage solids for their fertilizer. And the amount of that PFAS in the sewage they've used over the years, to shut the farms down. Is there any guarantee that these new plastics do not contain chlorine?
did you hear, Suresh? Do you want me to repeat?
That would be helpful. I couldn't quite understand everything.
So you did not, or you did?
No, I did not. So
Okay.
if
So
you
there
could-
is a lot of
Yeah.
there is a lot of concerns. Yeah, there is a lot of concerns. Yeah.
Contaminate your soil.
Yeah.
In the long run, keep using it.
Yeah. So there is a lot of concern, nowadays in terms of the PFAS, that's
Yeah.
a very hot topic for now. And he's asking how, how do we guarantee that the biodegradable plastic mulches are not, causing any problems in terms of this
Yeah.
part.
Okay, I'll answer that. And then PFAS. Good news is there is
Yeah,
no
as well.
PFAS in BDM or PE malts. There is no reason to use PFAS in BDM. We actually did a study, researched, and we have a fact sheet titled "There is no PFAS in biodegradable plastic molds." You can probably look it up. And it gives detailed information, but the short answer is there is no PFAS in BDMs. And I understand it is a big concern, and I know in Northeast, especially in Maine, some of the fields have been out of production because of so high level of PFAS, and it's very concerning. but luckily there is no PFAS in BDMs.
Great. Did I ask well? Did I correct it? Sort of.
Saying that spray with the shot, which, polyethylene is, that won't convert, if it does, or something, it won't get into the soil. That's,
Yeah.
so, they, safe thing is avoid polyethylene altogether.
Mm-hmm. Yeah, he's just, he's just concerning about, in the beginning.
In laying of the mulch materials? Yeah, I couldn't quite understand what he asked. I'm sorry. The voice is, not great from that background there.
So yeah, we will probably put you in touch with him and we can talk more
Sure.
about it. But
Absolutely.
just talking about the PFAS, yeah, thanks so much. Yeah, there is also one question. Do you guys have any other question to ask? Okay, so there is a question from a grower online, and he has a lot of problems with salt, Suresh. So he's concerned and he's asking, how does the biodegradable plastic mulch performs under cloddy soils, like very heavy soils?
We have done testing in variety of soils. Even in Connecticut, wide variety of farmers use it. The challenge would be in laying time. There needs to be good amount of soil moisture to be laid without doing much damage. So only concern I would have is to make sure that soil has good moisture, ideally at fill capacity, but a little less than fill capacity would be fine.
I thought
I do not see any other concern related to heavy soil.
Okay. So
When there are lots of, like in Connecticut, a lot of farms are named after stones or cobblestone farms, and
yeah,
they have
like-
enormous amount of stones in the farm, and they're still able to use uh, BDMs. Again, the laying would be a little tricky, and you have to adjust things like reduce the tension on the guiding wheels and things like that. But the soil texture is not going to prevent it from being used.
Okay, thank you. So it is possible to use
Yeah.
under these conditions. Okay, thank you so much,
Okay.
Suresh. Yeah, if you guys have any other questions, so we will share your QR code later on,
Yeah.
and they can get in touch with you if they have any other questions. Thank you so much.
Yeah.
So let me introduce the next speaker. So the next speaker will be Burdett Barker. He's our irrigation specialist, extension specialist here at the Utah State University, and I will let him introduce himself. Thank you, Burdett.
Great. Do I need to share with the folks online, or can they see it?
Nope. You just
Okay.
need to present. Thanks so much.
Okay, great. I'm Burdett Barker. As you now already know, I'm an irrigation engineer, and I appreciate you all for not leaving after I said that. So can I get a raise of hands? Who here is already using drip in your operation? Okay, great. How about people that are not using drip but interested in using drip? No one. You either decided you're using it or you're like, this is a good time to stand up. Oh, good. That's good. We got one. Okay. So I'm going to talk about drip irrigation management and stuff. So No matter what we're doing, do I have to stand by this thing so they can hear me? Probably online. I probably can't move around. That's cool. The goal when we're designing irrigation systems, managing irrigation systems, one of our top goals is to try to get a similar amount of water to every plant, right? Now you can have systems where we're intentionally trying to vary that. Let's not worry about that. Generally, we're trying to get the same amount of water to every plant. Who here has an irrigation system that gives every plant in the field the same amount of water? Good. That is encouraging, okay? Otherwise, we would have had to have this awkward conversation out in the hall later. Right, we know it varies, okay? But we want to reduce that variation. Okay, so as you know, we've got these drip lines, we've got emitters, and this is a little thing I drew up forever ago. Obviously, in vegetables, your drip lines don't look quite like this. One thing you could do is you can go out and you can capture the discharge from a bunch of the emitters in your field. Okay, you don't do that, but I do that. Actually, more accurately, my students do that. It's a really, really great activity for students. I do it sometimes, okay? Usually when I'm teaching them how to do it. Okay, and what we'll do, if you care, is we'll go down. If we got a field, we'll pick 4 of the laterals, okay? Because this is going to take us a minute. And we'll pick 4 laterals, and we'll take the field and we'll break it up into quarters and pick one from each quarter, maybe in the middle of each. And then we're going to go and we're going to sample maybe 8 or so locations along the line in equal intervals. Okay, so we've got 32 points from all over the field, and then we'll look how that performs. And we want it to be for drip in about the 90% range that we this variation we see there. Okay, meaning it's like 90% uniform. Okay, not 90% variation. We have a couple things that cause that, and it's important to remember that when you're buying drip products, when you're managing your system, what things can you do to kind of maintain uniformity? One is just the quality of the product that you purchase. Okay. Just because, I mean, think of all the thousands of emitters that you have all over your field, and that each of those got formed, okay, you know, in a plastic mold. There's variation. There's manufacturer variation, okay. So you want to look at those products. We like to have what we call a coefficient of variation. Oh man, spoiler alert. Okay. Don't click. A coefficient of variation of 3%. That's a measure of the distribution of how that runs. And so if we had a gallon per hour emitter, which is high for ag use, that's more of a landscape rate. You know, you would have, say, 95% of your emitters giving you between 94 hundredths and 106, 1.06 gallons per hour. You're going to have plus or minus about 6% flow on that, okay? That's just going to happen if you could have everything else perfect. And so if you have a lower quality product, it's going to be worse. And so a good manufacturer will be wanting to tell you what their CV is on their product. Okay. Now that matters. Anybody that's worked with pressurized irrigation knows if you give it more pressure, you get more discharge. Okay. And generally it looks like something like this. Okay. whether it's a sprinkler or a drip emitter, the physics is that it works kind of like this. Now, you can get a pressure compensating emitter, and what generally we have is a little bit of rubber or silicone or something that will flex with the pressure and restrict the flow as you have greater pressure, and so it can be pressure compensating. And so this curve will start to flatten out more. We don't really have a version where it gets worse than this, unless you're just poking holes in your line and using that as your emitter, okay? So pressure compensating emitters can be really helpful, but you don't always need them. A lot of times we can design a system, vegetable grounds usually fairly even grade. We like pressure compensating emitters when your ground is doing this number. If it's got pretty even grade, a lot of times we can do without pressure compensating emitters, unless you're in the situation where you have to feed from the bottom of the field uphill, okay? So that's not always a win-win. So you use some caution there. Usually we can use some design principles to get around that. The other thing is we have pressure loss in our system. Okay, don't worry about the numbers here. This isn't going to be real for your farm. It's just an example. And head and feet, you know, divide that by a little less than 2.5, and you've got PSI. Okay, this is from a class I teach, but you can have some target pressure, and most of your field is going to be under pressure or over pressure. It's going to be that way. We don't get to have it all at the same pressure, because the flow in the lateral and any elevation changes both are going to reduce pressure unless you're running downhill and gaining pressure that way. So a lot of times we like that. If you can have a little bit of a slope on your field, then we run our laterals downhill and we can get the elevation change to compensate for some of our friction loss. And you'll notice that it's worse at the beginning near the manifold or the supply line or the lay flat hose or whatever you want to call it here, because you have a full tube of water, and by the end you've got 1 emitter's worth of water running through that tube and it's just crawling along. Okay, so a couple things to just remember when you're getting tube. Don't go, you don't have to just go big, right? But it should be sized appropriately. Going too small can cause some problems. I don't know. I was just throwing this together weeks ago. Actually, I was doing it over here this morning for this first hour. So I'm probably too far away from that speaker. This is hard. I don't like this. I like to move around when I talk. No, it's okay. So you can see we have a flush manifold, and I'm going to come back to that. This is time number 1. Components of a drip system. Some way to supply it, okay? Some kind of manifold at the beginning. That's what we call it generally. That'll be your lay flat pipe or whatever, however you're feeding all your individual drip lines, which we usually call laterals. And then you have something at the end to flush it, okay? It might be a little valve on each line. It might be a little, usually in commercial veg production, we're not going to be able to just kink the hose, right? It's going to be tape. Some fold it over 1,000,000 times and clamp it. That doesn't work well on a large scale. If you've got a lot of stuff in your water, you're gonna want to put in some kind of manifold. Okay, that's my general recommendation, because we don't want to go. We also don't want to go cheap on flushing. Okay, so I'm going to shift over, talk a little bit about filtration. This is a photograph that I took of an actual sprinkler. That's kind of a joke. I drew this and I keep taking like a screenshot of it over and over because it gets worse every time I present it. But somewhere in my files, I have the original drawing that looks decent. This is what we design if it was a sprinkler, okay? Sometimes it's a little easier to just think of water moving through that little nozzle in a sprinkler. And we designed the filtration so that no two particles could be zooming along together and get stuck in that nozzle. Well, the size of particles that we work with in drip, we're talking about way, 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 way smaller stuff. We start to get things that they can clump together, okay? And we call it bridging. So when any one particle would just flow through, right? No problem. But a little group of them come together and they get stuck together and they clog your emitter. And that's what we tend to have in drip. And so this little 2 particle rule turns into an 8 to 10 particle rule. We have to screen much smaller for drip. And then we have the problem of what's the true size of the emitter. So what we do, we rely on the manufacturer to tell us what size we need. Now, when we're talking, a lot of times we're thinking about sand because we can feel sand, and sand particles are, if the biggest ones are 2 millimeters, okay? And that's the size of this giant circle over here, okay? And then silt, we get these little 0.05 millimeters. You can't even think of how small that is because it's really small, right? But when you feel silt, it feels powdery. And then we get the clays, okay? They're 1,000 times smaller than sands, right? So they're really tiny. And they stay in suspension, and they can cause us trouble. The silts and the clays are gonna be our problems with filtering for drip. Okay. How do I get something that's gonna filter all this stuff out? Well, you're not. Okay. You're gonna leave some in. And so remember, we talked about flushing. Just a minute, we're gonna come back to it. It's gonna be really fun. So if you're familiar with filtering, which you should, because you're drip irrigating, or you don't care because you're running furrows and you're not planning on drip, and so you're not sure why I'm talking to you. We do that in mesh size, right? And so a lot of times in drip, we're filtering down in this range, okay? We might get a little smaller, pick up some of our silts, but a lot of times we're letting most of our silt pass. Okay, it just gets hard to filter that much. If you have large sediment loads, okay, I was talking to a grower down in Green River yesterday, right? You ever been on the Green? It's a muddy mess a lot of the time, right? If you've got really high sediment loads, you're gonna have to filter more, okay? We can get away with a little more in a lot of areas in northern Utah because our sediment loads tend to be less, okay? But a lot of times they're gonna recommend somewhere in this range, maybe 140 mesh or so. You certainly don't wanna go larger, which is a smaller mesh size, smaller mesh number. Okay, is a larger particle it will pass. So I want to quickly look at some filter types, and then I'm going to try to kind of be done. We have 3 main technologies for filtration in irrigation systems. We have screen filters, disc filters, and media filters. A lot of people running media filters. What are you running? Anybody running just screens? Okay, we have a little bit of that. Anybody running disc filters? Okay. And then who do we have running media filters? Okay, so we have a pretty good mix. And so for most applications in drip, you can use any of those technologies. If you're really heavy in what you're trying to filter out, you might want a combination. Screen filters tend to be on the less expensive end, but sometimes have hard times with if filamentous algae, they can struggle with that. They typically have lower flushing requirements, right? And so that can be nice. This is one we have on a subsurface drip system out in eastern Utah. Okay. Here's a bank of media filters out in Howell, also on subsurface drip. We get some of our subsurface fields are a little bigger. I have some good pictures from them, right? Media filters are nice because they can handle really almost anything you throw at them, but they get really expensive really quick if you have large filtration needs, okay? Or if you're gonna, they also have large flushing requirements. So to flush, you run water back through that media and it suspends all the media. We used to call them sand media. We just call them media now because it's not a true sand that's in it, right? They have engineered products. So the media, these little particles float up and all this stuff they've caught is supposed to kind of come out of suspension and float up and go out the discharge manifold, okay? That's fine, but it takes more water to do. And so if you have a high filtration need, these can blind off quick. So one solution is more filters, and other solutions, maybe a different technology. Really good on the fine end though. Disc filters, I'm a disc filter lover. Any kind of filter, you're gonna find somebody that likes it and somebody that hates it, okay? So there's no silver bullet. If you're not familiar with discs, this is just a little one I bring around. This is like one you put on a hose bib, but it's harder to bring in a bank of disc filters, so I bring this. But you have this set of discs, okay, and they're a lot like a poker chip, okay. They have little grooves, but instead of like poker chips, the grooves kind of fit together and they stack up. These grooves don't quite line up, okay? It gives you a lot of filter area when those discs are all compressed together. And then when you back flush them, you run clean water in the discharge, and it pushes against, there's a spring that holds these tight, it pushes against that, and they all become loose, and the water can flow out, okay? And so we tend to be able to get a pretty good flush with a pretty simple mechanism on disc filters, but they tend to be on the expensive end. I said it was coming back. We're never going to be able to filter our way out of the need to flush. And we don't have, there's not a toilet plunger for drip irrigation, right? If you fail to flush and get sediment problems in your lines or start clogging emitters, you'll never recover, okay? Never be able to fully recover from that. One of the biggest things on the performance and life of a drip system is how much you flush. Anybody, no, I won't make you. I was going to say, anybody want to share a testimonial of not flushing and the fun experience you had with that? I think you can share anything you're willing to share here. This is a safe place, right? This is an example of a valve on an onion field, a little flush valve. They cost a little more, but it can be really convenient if you go that route. I'm running out of time, but the one last thing I wanted to share is just know your rate. Okay. This is more of a thing they like to pound into homeowners. They're like, drip irrigation doesn't use any water, right? But you know it does, right? Because you've seen the size of pumps and filters and main lines you need to run your drip, okay? We're just changing what it looks like. in general, the way the drip industry is going, the technology we're trying to get, I pretend like I'm one of the people developing these things. We're pushing towards more, smaller and smaller discharge emitters, right? Being able to just keep those rates really low, okay? Now, it depends on what available, you know, most of our producers here are going to be off a canal, so you're going to have these limited, you know, frequency that you can irrigate. And so having a little bit higher discharge is fine if that's the reason you're doing it. But if it's just because you feel like you need to be able to irrigate the field in a couple hours, that's maybe not the best reason to do it, right? These low flows let us keep more optimal water contents in the soil and help us get a better spread of that water than if we dump it on and saturate it. Then we tend to get we tend to water long, skinny areas instead of nice kind of spheres. Okay. And then this is, you know, everybody loves equations, right? Because we're all engineers. And so if you take your gallons per hour times the number of lines you put per bed, a lot of times that's 1 times 230, because that's a fun number, and divide it by how far your beds are apart and how far your emitters are apart, you can get how many inches you're putting on in an hour. And so that's kind of fun to remember, to try to match that. I have some, you know, we can talk about more. I have some stuff about how, you know, if you're using soil moisture, I think that's really important in vegetables. But I'm going to cut it there because we're all running behind a little bit on the program. So if you have questions, I'll take them. I'll be around. But I want to make sure you have time to talk to the vendors and stuff. So, okay.
If you have any questions, you can ask him while I get the other slide. So right now, as you can, I think you can see in the program, I think you've got the agenda. We do have a couple of colleagues from Utah State. They are doing a lot of surveys projects, and they want to share, advertise. And if you are a vendor, you know, if you want to have a few minutes to, you know, to announce, that is the time. So let me just, I do have some slides. So Jose, yeah, you guys can come. Yanam, you can also come here. So Emily, yep. I think Claire will be the first. And then after that, we are going to have a break, and then we will come back with 3 more presentations, all right? So yeah, Claire will be the first one. Yeah, I will just pass the slide. Yeah,
just
okay.
pass.
You are the first one.
Okay,
you just
okay.
speak.
Cool. Hey, good morning, everyone. My name is Claire Entwistle. I'm the Extension Water Quality Specialist at USU. I'm fairly new to this role as well. I just started in August, so I'm really trying to kind of make my way around the state, introduce myself, and kind of let you know that I can be a resource for y'all. There's my contact information. I'm also just trying to help understand what are some of the needs for different groups around Utah related to water quality. One project that I'm working on with another professor that you'll hear from today is looking at harmful algal blooms. They're becoming more common in a lot of reservoirs where people might be using that water for irrigation sources, and there are some risks that can impact crop health as well as also human health if it accumulates in tissue. So I have a couple questions about that, but then also just kind of want to know what other water quality concerns you all might have. I've heard a little bit about salinity and PFAS, which can impact soils and also water quality. So if y'all could scan the QR code and answer a couple questions, I really appreciate it. I also included our kind of water quality extension page, which has a lot of great resources there, some irrigation water quality sampling guides that Burdette made, as well as some other helpful tools. And then,
Good morning, everyone. Similarly as Claire, I'm new at USU. I started in August too. I'm the new extension specialist in entomology. For those who have been around for a while, I'm replacing Diane Alston. I'm located in the Department of Biology. And like Claire also, I'm also trying to understand what you're doing, what's your practice, your pest management practices. So I have need assessments on the top, and you can also find some information about my lab with a QR code below. I also have some paper version of my need assessments if you prefer to take the questionnaire on paper. Before that, I came here. I work in Florida for 8 years. I work on citrus, so I work a little bit on vegetable, but I'm new to it. I'm willing to learn. I have a lot of things to learn. The weather and the insect community here is really different. So I just want to add 3 things. One, I'm trying to get funding. We're working on a thrips resistant project proposal with Claudia. I have some cover letter or letter of support. If you have problem with thrips and you want to support this project, please come see me at the blue table down there. You can sign the letter for me. That will help us get funding. Then I'm looking for a field with squash bugs issue to do some study for master student project. So if you have squash bug issue, also please come see me. And finally, we are also working on a pest guide for berries and grapes with Mair. We got the funding, so keep your eye on that. I will be advertising that. And squashback thrips, I have another thing and I forgot right now. But please, if come to see me in the back of the room whenever you have time, introduce yourself, and we can talk about pest issue. I will be happy to learn about what you're doing. Thank you.
Hi everyone, I am Jose Brandao. I am the Food Safety Extension Specialist, and I'm here just to speak a little bit of my program and also to announce an opportunity that we have with Milena and with Dr. Park. Basically, I am here in Utah to help any business, maybe not so much growers. However, if you have any problem with the product safety rule, I can also answer those questions. However, something that I want to remark is that we are going to be offering good agricultural training for producers. I don't know how many of you are familiar with GAP. So basically, GAP can open markets. When you start small, you never hear about GAP, but as soon as you want to go to those big supermarkets or distributors, aggregators, they are going to start asking for GAP. And what we want to do is not just help people train on what is GAP and get that certificate and sit in a classroom. We would like to have the opportunity to go to your farms and train everyone in GAP, so your workers understand also what is GAP, why it's important. And I don't know if this is the situation of anyone, one of your workers or many of your workers speak Spanish, we can provide that training in Spanish or in English, whatever works for your farm. We want to do this in a very localized manner, and we want also to do it in a broader sense. We are going to be working to get dates in the future. Right now, we are still planning, but we have funding to do this, so there will be no cost attached.
Thank you. Just a second.
Okay, hello everyone. My name is Namhyun Park. I'm a food chemist. So in my lab, we use enzyme technology and also fermentation to address some of the challenges in the food industry and then food sciences. And especially today, I'd like to introduce one new project I am trying to develop. So I believe some of you are maybe familiar with kimchi as a fermented spicy the napa cabbage. But actually in Korea, the kimchi include a wide variety of the different fermented vegetables, each with different ingredients and then flavor. So in this project, I'd like to develop some new type of kimchi, especially as like Western kimchi using locally sourced agricultural products. So the project is still in the stage of the proposal development, but today here I would like to connect with someone, any of you who may be interested in this project and potential collaboration. So yeah, so I'm happy to, if you are interested in this project for collaboration, please contact me using my email, call, or after this session, we can have a quick chat. Thank you.
Yeah, thanks so much. So as you can see, we are a very new, group of folks. Only one American, the other one's internationals. But we are here to try to understand you guys better and to work with you because our work is to serve you guys. So we need to connect with you. If you guys could be, as closer as you can, and share your problems with us. We love problems and we love more. We love to solve the problems actually. So those guys will be here. And if you have any other people who wants to announce anything. Yeah, sure.
Yeah, thank you. I'll be very quick here. My name is Randall Bagley. I'm the program coordinator for Agribility of Utah. Agribility is a program that's been around 30 years, and we're sponsored by and funded by the USDA. And our main goal is just to help farmers and ranchers with disabilities. So if you know of anyone that has a disability, we'd love to see if we could help them. We do that by helping provide equipment. So we're just basically in Utah, and it's a free confidential program. So please come and see me. And I got a lot of brochures back there. Thanks.
Thank you. Yeah, sure, Steve.
Sure.
Go ahead.
I'm Steve Pettingill, and I'm going to be representing Irrigation Irrigation Products from Fresno, California. I've been a leader in the industry for a lot of years. They're based out of Italy. Most of the products, nearly all the products, are made in the United States in Fresno, California. We specialize in drip products, also for orchard, also for field filtration products, sand filters, and screen filters. So if you have any questions, I'll be back there as we break.
Thank you. Thanks so much. Michelle?
Hey.
We are out of time.
First of all, some of you heard from me last year, so I'll be super brief also. I work with the Utah Transition to Organic Partnership Program. If you are interested in getting certified organic, no pressure. If you're interested in getting certified organic, please reach out to us. We have mentorship, support, technical assistance, fact sheets that we can connect you with. But we're also doing the Utah Organic Farming Summit. Organic really is a growing industry in Utah. It's very small, but it is growing. So we're really just trying to get everybody together. We have a number of research-oriented talks. We'll have a couple of buyer speakers, people you can sell to. We've got really specific practices that are relevant to Utah in a handful of farmer perspectives. They'll include lunch. It's in Salt Lake City. We'll also have field days coming up over the summer. You can go look at an organic farm if you're like, this is impossible. You can go and look at one. So all my info is back there. I'm really sorry. I do actually have to leave right around the break. So I'll leave some of the brochures and my cards, but I'll be back there for a little bit at space with you.
Thank you, Michelle. Yeah, is there anyone else? No, so we are going to the break. We are probably past on time. The break will be on the hall. Yeah. Mike will guide you guys. So sorry about the media today. So they replaced this whole thing during the weekend. So it's not working as, we expected. So thanks so much for your comprehension. Yeah. So we will see you back later due to the room, like 20 minutes, I think we'll get probably. Yeah. Thanks so much and interact with us if you want to.
How do we load it up?
Okay, yeah, sure. Let's. Yeah, it's over there. You can just- yeah, let me get for that. That's mine.
We can put it on the desktop if that's easier.
Yeah, yeah,
It's
sure.
a pretty big file.
Which one?
Lots of
one?
Utah talk.
Utah.
Well, that copied correct.
Yeah, it did.
Let's just, can I just open it up?
Yeah, I can remove that safely for you. Yeah, go ahead. James, so what are you gonna do after here? I mean, are you heading down? How?
I can stay for
Try-
lunch and.
Okay. Do you have any preference? Because I don't know anything here in Brigham. Mike can take us.
Oh, okay.
Which kind of food do you like?
Just not Thai food because I had that last night.
Do you like Brazilian? Yeah, as I mentioned. I don't know if we have a Brazilian restaurant here. I don't think Logan we do. Are you going through Logan? Are you going?
Probably not.
Where are you going?
I don't know. I think I would.
I think you are going. If you are going, are you going to Idaho? Are you driving back?
Yeah, but I might go that way from here.
Okay.
So.
Yeah, because we do have a very nice restaurant in Logan, and you could. I don't know if you have been in Logan before, so you could stop.
I drove through it last night because.
Yeah.
But I won't go through Logan.
So I'll ask
go
you,
back this
David.
way.
One second.
Mallet City, isn't it?
Tremont. I think you are probably. I don't see Logan.
No, it's.
There is no Logan.
It bypasses Logan. Logan, I have to go.
Oh, okay. So you are
Logan.
going to
Yeah.
through Tremont.
Yeah.
Okay.
But I did come back that way. I visited growers around down here.
And
last
and
night.
did you came by flight and are you driving back or did you
No, I
drive?
drove.
You drove?
It's only 4 hours.
Oh my God!
It's only 4
You
hours.
drove.
No,
Thank you
like,
so much.
I had to visit a grower in the Preston area last night.
Mhm.
So
Okay, sounds good.
let's
Yeah,
see
everything
if
is
this.
ready.
Let's see if this just.
This is for that. Yeah, I can just close this.
Just want to.
Yeah. Do you want my presentation? Okay.
Okay, and are you going to tell us or? Okay,
Whatever works for you.
Take care. Yeah, let me grab it. Okay, thank you, Katie.
Yeah, look.
Okay, yeah, go around. Oh my, Steve, this mic.
Just 1, 2.
Okay,
That's not good.
thank you. How are you?
Good. How are you?
I am good.
Good turnout. That's awesome.
Hey, I really thought Tony would have retired, but he's not retired. I mean, he
No,
just
he
just moved.
Yeah.
I don't know him, so I was talking to Matt Yost.
Oh,
And
yeah.
Matt,
Yeah.
I don't believe he's retired because he's
Yeah.
still young.
Oh, he's still got a couple years.
So what is he doing? Biostimulants. I lost our. Yeah, I do have a lot of. No, she's coming back. So I do have a student. Well, he's a retired army. He's retired from army. David Fiedler. Do you know him? Maybe he knows you guys. So he lives by Garland. Very close to him. So I do work with the biostimulants. A lot of biostimulants. So. Oh, you said you do manufacture? Just give me. Okay, so no microbial.
Test 1 2 test test 1 2 test test 1 2 test 1 2.
I'll be right back.
I don't have my card. Yeah, sure. Yes.
Test 1 2. Right now, test 1 2 test. Not hearing much. Test 1 2 test.
Quando eu vim morar, meu estudante, ele também faz foi no teste.
Test 1 2 test. Test 1 2 test.
Sim, por causa da missão.
Handheld test.
Yeah, very close. Let me see. We moved here. So that's my contact. Well, or you can just see on my phone. Yeah, so I'm.
Test 1 2 test.
Do you have my email? Do you receive my email? Yeah, Mike is the one who's sharing. Okay.
Test.
And yeah, and here you cannot find my email. You can text me and I can text you.
Test 1 2 test. Can you see anything? Testing 1 2 test. It's noisy enough. I can't really tell. It may be. Yeah, I think it's there. Yep, it's there.
Okay.
Sorry. So, so the handheld is controlling the lapel, and the lapel will handle. Test one, two, test. Or it kicks in, and we'll leave these on. This is that control. As long as you're green, then zoom land and everybody can hear that as well. Test 1, 2. And I'll be in the room.
These guys. Okay, so the pointer.
I wanted to ask,
Yeah.
can you send a follow-up email?
We will send a follow-up and then I will get you guys, I will probably send the slides.
Okay,
If
perfect.
that's the best for
Yeah.
you guys.
Yeah, that'd be
So we
perfect.
can send the slides.
Okay.
Did anyone reach out? Don't worry, we will get you some growers, yeah. Also, I want you to talk to you one thing. There is a grower in Green River, that grower.
Yeah.
I want you to talk to him. He
Okay.
has heavy soils.
The one that
So-
was like on the
Greg
Zoom?
Vetteri.
Okay.
Greg Vetteri. So he has heavy soils and I don't know if he is probably one grower, you know, a good grower, so you could talk to him
Yeah.
later.
Do you,
Okay.
you could send me his contact information or you want?
I can send you, didn't I send you already?
You did send me, I'm trying to think if that was the name of
Right.
the, let me go back. It might be.
Okay. So now is it working? This one?
So if you're in
This.
PowerPoint, you can use that, but this is your highlight, basically. And you
Okay.
could aim it there and it'll control, or if you're looking over here.
It's pretty
Okay,
big.
so he was.
Yeah, so, and
Okay.
then in your PowerPoint to advance forward or backwards, basically.
Okay, sounds good. Thank you, Steve. We don't have any other, presentation online.
Oh, you
For
don't?
now. No. So is the recording going on,
The
right?
recording is still
Okay,
going.
thanks so much.
So
we will chat.
basically, we're just all face to face and with the Zoom component.
Yes, yeah, sounds good. Thanks
Okay.
so much.
Um,
I think I have my presentation. Let me get my presentation there. So I can use,
And his, you
yes.
said like salinity or the?
Salinity, cloudy soils, and. Okay.
I need permission to take this bucket. Okay, can I have this bucket? Oh, give me a raffle prize? Okay.
Yeah.
Tegan will project it from now on. Tegan will project I know.
And then if you have
Right now. I know. Hi everyone, can you hear me? Hello. Let's continue with our presentations, please. You guys could chat more later. So right now we're gonna have a presentation on plant pathology. So I've got James, and he's from the University of Idaho. Thank you so much, James, for coming. We are very glad to have you here today. And if you guys, have any other questions for the other speakers, you can ask, through email, or you can email those questions or text me, and I can get back, to those guys. Thanks so much. You could, yeah. I could probably use this one. Thank you.
All right. Good morning, everyone. So I'm a plant pathologist based in Parma, as you can probably tell from my accent. It was quite funny when I was driving down the main street today. I went past a store that said Chimney, fireplace store, and it made me think of home of England, and because of Mary Poppins. And it's funny, in England, whenever we hear an American doing a really bad English accent, we say it's a Dick Van Dyke accent. So it made me think of that. But yeah, I'm based in Parma, and it's just 5 minutes from the Oregon border, 42 minutes from Boise. And we have some new labs. So the labs there, it looks kind of uninspiring, that building, but it was meant to be a $7 million lab complex. It ended up costing $15 million. So it just shows how costs overrun. And a lot of my lab is molecular diagnostics. So in there's a lot of air handling units, which maintain pressure between labs. And they're pretty nice labs. I'm pretty privileged to work in them. So what am I going to talk about? Well, first of all, I'm going to talk about onions, and then I'll go into sugar beets. I know there's not many sugar beet growers here, but it's the vegetable crop that I really work on the most, probably. But hopefully some of the stuff we're doing on drones and fungicide resistance, you can take and apply to other crops. And then a bit on peppers, and then, I'm from Idaho now. I've got to mention potatoes, and we're doing some novel stuff with soil testing. Okay, so onions. One of the most frequently submitted diagnoses to my lab is onion bacteria rots. And this is what we see, this kind of ring in there. This is actually center rot caused by a bacteria called Panturia glomerans. A lot of people get it confused with something called translucent scale, but it is actually a bacterial infection. The other thing we see a lot of is Burkholderia as well, which kind of rots the whole onion inside and out. Now, the one thing I want to say is we've actually done a survey of about 1,500 bacterial isolates from Idaho and Oregon, and we tested them, all of them, against different bulbs. And you can see a wide range of those species can cause decay. So the take-home message from this is, you know, it's not the bacterial species you have to worry about. That kind of modulates the severity. It's really what is initiating that infection in the first place. And like fungi have a means to get into the plant. It forms an infection cushion, or an oppressorium and a haustorium, which are infection structures, to get into the plant cells. A virus can get into plant cells with its insect vector as well, you know, basically just an injection into the plant cells. But bacteria can't do that. They're just cells. They have to have moisture and or wounding to initiate disease. So when we're thinking about bacterial diseases, if you do have them, those are the two drivers for it. The other thing that bacterial disease can occur from is kind of piggybacking on other diseases. So we have this symptom we see a lot of, this dry leaf or brown leaf. This one is a little bit more. And that can occur in Idaho. And I think that's when the plant is shutting down in the high heat temperatures in the summer, and you just end up with this dried leaf. However, sometimes this dried leaf, it can get colonized by a fungus. This fungus is Fusarium proliferatum. This fungus, Fusarium proliferatum, is everywhere, and if you grow corn, the levels of Fusarium in the soil are way higher than if you don't grow corn. Anyway, this fungus can get in, start decaying those scales, and then eventually it turns into a bacterial mush because the fungus kind of creates the moisture. Now, what's interesting is if you look at the temperature of onion growth, the optimum growth temperature of onions, okay. It's around, I don't know, 28 degrees C. Sorry, I can't do it in Fahrenheit. What's it in Fahrenheit? Do you know? I don't know, high 80s. But what's interesting is that that's where onions starts to, you know, not grow in the summer. And then just above that optimum growth temperature for onions when it starts to fail, the optimum growth temperature of Fusarium proliferatum and Panthoea glomerans is just above that. And that's when it can colonize that leaf and cause your rots. So that's kind of an indirect thing, and that's what we're seeing in the Treasure Valley. The other thing we're seeing with bacterial diseases is when it piggybacks on Stemphylium. So Stemphylium is a leaf blight. It's a fungus that causes a leaf blight, and this is what it was like in 2023. The onions were just dying standing up, and you know, normally we'd want them to fall over and the necks close and you don't get anything in it, but they were dying upright, and essentially that meant it was like a straw, and the moisture could get down into that bulb and create the rots. So it kind of piggybacks on Stemphylium. So that's the other reason why we see some rots. And then this is what we saw. So to combat or to provide growers with an early warning for Stemphylium, we're actually doing spore trapping as well as monitoring weather conditions and humidity. So we know Stemphylium likes humidity, so we send out alerts based on that. And then we also send out alerts based on spore trapping. And this is the spore trapping data we've got. It might not come through, but the take-home message is in 2023 and 2020, where we had really high Stemphylium years, you can see that we did get higher levels of Stemphylium than, say, 2021 and 2022, when we hardly saw any Stemphylium. So we're using spore trapping, which we're also using for potatoes, and these are the spore traps we use. They're called a Burkhardt multivial cyclone trap, powered by a solar panel, battery backup. Spores are sucked in through there. This is a close-up, and you've got an orifice there, and you've got these tubes. And what happens is every 24 hours, those tubes move around, and then you've got 7 consecutive days of spore trap tubes. My crew collects them on a Monday. We extract DNA from them, and then we test them for Stemphylium, late blight, Cercospora, all the diseases we want. And then we send out an alert to Idaho and Eastern Oregon growers based on that spore trap data and some weather data as well. So this is what our spore trap network looks like. We have usually about 12 traps a year, and we're getting really good now. We've been doing this for about 8 years. We're getting really good at situating them where we're likely to see an outbreak. This is what we saw in 2018 with late blight, and you can see the line is humidity and the bars are late blight detections. And you can see we get that peak of humidity and then the flush of detections shortly afterwards. And then this is some data from this year. We got 2 weeks of consecutive late blight detections, and I phoned up the crop consultant who gave me that field site. I said, "Hey, you better get a spray on." They put a spray on, you know, and then we did see some detections afterwards, but you can see we stopped this kind of consistent flush of spores. I didn't think they were going to get much disease anyway with the weather conditions as they were, but it just shows it's a dynamic system, and it's evidence that it might be having a positive impact. Okay, on to Cercospora leaf spot, which is a disease of sugar beets that seems to be increasing in importance in the Treasure Valley. We're doing some spore trapping for that, and we can kind of monitor infection, and we can send out alert when that kind of disease levels ramp up. As you can see, it was kind of like at the beginning of August this year, but usually we're kind of monitoring for that anytime from July the 4th. So spore trapping is kind of useful to inform when we need to get our first spray on. And then also to investigate Cercospora, we did a series of field trials. Basically, one to work out when and how much we should be spraying. Another one to investigate the effect of nozzle size and spray volume. That was to look like a lot of people want to spray by drones, and there's so much conflicting information out there and urban myths about how useful these drones are going to be for disease control. I mean, obviously, people have done the spray card experiment with drones, and it looks pretty poor compared to like a ground rig with a higher gallons per acre in water applied with it. But we wanted to see the actual effect on disease rather than just sort of indirect with the spray cards. And then we also did an effect of protectants, tank mixed in as well. So first trial, when do I spray? So we tested different spray regimes and, well, you know, when we sprayed and the interval, you know, is it every 2 weeks, every 21 days and so forth. But one thing I just want to bear, you know, most things were kind of the same this year. I mean, we got some numerical effects with more often spraying. But the one thing I want to bear in mind is that when you sprayed by symptoms on a 21-day interval, you know, it was a little bit of a lottery. You know, 1 year, it was as good as all the other treatments. Last year, it was significantly worse. So I know, like, if you're coming from the entomology world, they all talk about thresholds and when you see a spot. I personally believe that with plant pathogens, you need to be proactive. Okay, this is our second field trial looking at, you know, simulated drones or aerial applications. And it's very challenging to do, you know, obviously putting it on in an airplane in a split plot experiment, but also a drone. So my graduate student, Hayden, at the time, he kind of did this simulated aerial application with a backpack sprayer just to see that effect. And then we just did different GPA amounts with ground boom as well. So this is the data from that. Obviously, every spray had a good impact compared to untreated. But the one thing I want to, you know, we did aerial applications. Those all seemed a lot worse than anything on with the ground boom. And what was encouraging, if you do like to use a drone, at 5 GPA, there wasn't any significant difference really from using 35 GPA. So, I mean, I get really frustrated. There's 3 research groups, including mine in Idaho, doing work on drones, and 2 of them have sort of said, it's bad, we've got worse results with drones. But there's so many variability, so many variables to consider. You know, the speed of the drone, the GPA. I mean, some of them are putting on at 2 GPA. You know, I think at 5 GPA, my data shows it's still working. Some of them are doing different height. I mean, height does make a difference. It wasn't massive, but there was a significant difference there. But I think my take-home message from that is, if you want to use drones, and don't be so much worried about the lower volume of water you're applying with it. Okay. The other thing we're doing with Cercospora is there's a massive problem with fungicide resistance, and it is developing. And we're doing a method called RH-AMP. It's kind of like a PCR method, but it enables us to differentiate one base pair difference. And theoretically, you could submit a leaf to us, and the next day you could get an answer what that isolate is resistant to. So it's essentially just a genotyping method. And then we're experimenting with this using sentinel beets in the field. So we want to put out, we grow sugar beets out in the greenhouse several weeks ahead of where the commercial crop will be. We put them out in the field. That will tell us if we've got Cercospora, if we see them on the sentinel beets, but then we also do RH-AMP on the sentinel beets, and we can tell the growers, hey, you've got some fungicide-resistant strains there, don't use this fungicide. So that's what we're doing with that. That hasn't come out very well, but this is some of the data we've got with RH-AMP and the populations we've had over the year. You can see almost everything is resistant to Quadris and the QOIs. Topsin significantly less, and that's kind of encouraging because we're using that. And the triazoles, which seem to form a backbone of any spray program for Cercospora, there's a lot of resistance there, but I don't think we can move away from the triazoles just yet. Okay, and then the importance, this slide shows one trial where we had an untreated, the local standard without any protectants, and our usual spray program is Domart, Topsin, Inspire, and Priaxor. And you can see there was no significant difference there between that and untreated. But if we did put in, mix that local standard with either Badge or Mancozeb or even Bravo, which is not registered for sugar beets, but it is used as a protectant elsewhere. If we mix it in with a protectant, we do get significant difference. So I think for a fungus like Cercospora, where there is the chance of fungicide resistance, you really do need to tank mix with something like Badge or Mancozeb. That does make a difference. And I know if you're from the entomology world and you're familiar with insects, they don't like you tank mixing, but I don't think we can move away from it with fungi. Okay, and yeah, I just want to say, if you're spraying at symptoms, you can't be like Angela from Landman, be really good at gambling, because it is a bit of a gamble. So, who watches Landman here? It's a great show. So, yeah. Okay, on to my next example, and this is tomato spotted wilt virus. And in Idaho, it was a bit of a tomato spotted wilt virus. I've never diagnosed it before, but we actually had 3 in this year. And it was beans in the Treasure Valley, peas in the Magic Valley, and peppers again in the Treasure Valley. This is what the symptom looked like on beans. And this went to another lab, which I won't mention, and they said it was halo blight. But thankfully, they also sent the sample to my lab, and I proved it wasn't halo blight using real-time PCR. It was tomato spotted wilt virus. This is a thrips transmitted thing. And in peppers, we saw it in peppers causing these kind of spectacular symptoms. It can look a bit like sun scald, but it wasn't. And you can see the viral arcs on there. What was really interesting is it kind of, I think, they cut some land next to the field, and it kind of agitated all the thrips in that kind of rough land, weedy patch. And then they moved into the adjacent pepper strips and kind of spread that way. And they just hit the pepper crop at the right time for them, the wrong time for the grower, and caused these symptoms. Okay, and it can happen on potatoes, but we didn't see it in potatoes this year. The one thing we see on potatoes a lot, and this is like, I would say it accounts for like 50% of all the samples that come into my lab, is powdery scab and PMTV on potatoes. So powdery scab causes these kind of blisters, and PMTV is a virus, and powdery scab vectors PMTV. And these internal necrotic arcs is called sprang, and growers don't know about it until they start cutting it open, and it can develop in storage, and processors don't like it because you can actually see it in the French fries. So there's some pictures of the PMTV. Okay, and these are more pictures of Spongospora. When it's fresh out the field, it really is kind of raised rather than those sort of open blisters. Okay, so what are we doing to combat that? Obviously, with a virus and a soil-borne disease, it's really hard to spray for it. I mean, there's no real sprays except for fluazanam maybe for Spongospora, but people don't say that's economically viable. But one of the things you can do is test the soil. So my lab offers a soil testing service for these and a range of other potato pathogens. We can take 300 grams, and for $75, we can test for both. And what my lab does that's unique is we can test for both DNA and RNA. A lot of labs will test DNA and RNA separately. For us, it's a combined test. So this is the kind of outputs you get when you submit a sample. You kind of get this result. And I just want to draw your attention to, for Idaho growers, we rank every soil we get. So you get your risk, based on your level of inoculum and what we've determined from field trials to be the relative risk. But we also give you a ranking. So this is what it looks like. We rank all the soils. And I know we do this for a few Utah growers as well. But you can see where you are. It was pretty cool. The one day I said, well, to one crop consultant, I said, you should be very proud. You have the most infected soil in all of Idaho. That went down really well. So, but it's useful information, They've got bragging rights if they manage to control it from that as well. So it's good information, I think. And this is like our risk categories for Rhizoctonia as well. And we do a color code system. So the one thing I want to say with all soil testing, and there's a lot of labs out there doing soil testing, is you need to have a biologically relevant sample size. This is kind of really true for some fungi, like which form a sclerotia. Those sclerotia are kind of big. I mean, if you're just testing a few grams, you're unlikely to catch it. You've got a small net rather than a trawl. And we actually use buckets and a paint shaker to extract the DNA from these large soil samples. And then this is actually from another soil testing lab with their recommendations on how to sample soil. And you can see I'm pretty sure this is what you buy from Walgreens to take earwax out your ears. So, it's kind of crazy. You want to get more earwax than soil for your soil testing. I mean, when you test a field for anything, you're basically sampling infinity. It's kind of crazy, Like, I know nematode testing is pretty well established, and we're taking, a few pounds of soil for that. But a few pounds of soil from a field is crazy. But this is certifiably insane. So the more sample, the better. Okay, so how do we do it? We do a real-time PCR, and then we get a level of inoculum, and then we can work out. So these are our targets that we do for potatoes. We've also moved into onions for pink root, and we know if you're about 0.81 femtogram of DNA of pink root DNA, we know we're going to get severe disease. So we've got the threshold for that sorted. And yeah, we're working on that we've got tests available for a wide range of potato pathogens as well. And if there's anything you're interested in, we've got a very cheap sort of generic system for extracting DNA from soil and giving the results. If there's any crops that we're, targets you really want us to test and you think soil testing will be really useful, please let me know. Okay, so just to conclude, I really do think molecular diagnostics can really aid agriculture. There's a lot of lookalikes out there. I think soil testing and soil spore trapping are really good examples of predictive diagnostics where we can get ahead of the disease curve. And then I think I don't know how many people here are interested in using drones for using sprays, putting sprays on. I think there's a lot of future in it. And I think we've got a long way to go, but there's a lot of potential. And don't be put off by those naysayers who say you need to put on lots of water with your fungicide. And then I'm happy to take any questions after acknowledging my funders. Thank you very much. Yep.
So one of the, you brought up in the very first slide, the disease that takes the rings out of the onions. So that's a major issue. Is that tied to, is this a heat period where the onion shuts down for a period of time when that's developing? And have you been able to diagnose when that needs to be dealt with? So there might be a stress relief type application or something like that that helps to that up.
That's a very good question. So yes, so that Pantoria dominance is always present in onions. I can always detect it. And I do detect greater levels of it when we have an infected bulb. And bizarrely, it's like one of the first ones. So we can inoculate Pantoria dominance, and the inoculant will go like that for Pantoria dominance. Okay, bell-shaped curve. But the symptoms will carry on going. When Pantoria disappears, the symptoms are going. So I think Pantoria, because it's always there, it's one of those first ones. Then other things like Enterobacter can come in, and I genuinely believe it's taking off as the onion is shutting down because of heat. Yes. Now the reason why it's taking off, I think, is because of moisture, and that moisture can either come from the rain or splash dispersal, or it's coming from Fusarium filtrata, which is breaking down that ground leaf initially, creating the moisture, and then the Pantoria comes in.
Within the top part of the, within the top part of the egg.
Yeah. And the one thing is a lot of people are getting confused with translucent scale and Pantoria tolerance as well. But the translucent scale or watery scale is very, I can show you some pictures of that as well, but it doesn't have that brown or grey leafy brown that the Pantoria does. So, yeah. But like I said, I don't think it matters what it is. It's moisture is the driver.
So I'm not familiar with you in the last several years, but I used to work in the Little Valley with onion growers. And what you've done is amazing. I am so impressed. So, and I haven't met you before today, so.
I wish I recorded that.
Yeah.
Well, I'm missing an item meeting to come here today.
James, it is recorded. It is recorded. So.
What's the phone number contact the lab?
It's online, and I think it's Milena, you can send out.
We can share. Yeah, we can definitely share the contact. So all the contact information for all the speakers will be in a slide that we're going to share. Okay.
If you, I know Claudia as well, and Claudia's always welcome to send stuff on from you.
Is Claudia here?
If you need
I think she left.
Specific tests. I mean, both Claudia's lab and my lab are part of the National Plant Diagnostic Network, and I get a little bit more money than her because part of my job is to kind of help the other states.
Do you do any device testing for plant diseases?
We have the capability, but we don't. We try and do real-time PCR as our first thing, basically, simply because over in the long term, real-time PCR can be cheaper.
Do you think it's more accurate? You're talking about for viruses, right? Do you think it's more accurate?
Yes, it's definitely more specific. ELISA will be detecting protein, that protein being numerous things. If you go onto the Actia website and look at their antibodies, I mean, they can pick up 20 to 30 viruses. But it's just a tool. It's like a lot of people are scared of molecular, and some of the traditional mycologists or nematologists don't want to do it. But it's just another tool. It's like, hey, I've got an electric screwdriver and a drill, but I still got one of my favorite tools is just a normal screwdriver. I still use that. So it's just down to how you deploy those tools, really. I just like buying lots of expensive equipment.
We like to test. That's the word. Yeah. Yeah. Is there any other question? Yeah.
So you're sampling for Staphylococcus spores. Any thoughts about where those spores are coming from?
this might be controversial, but my theory is we think a lot of these foliar pathogens are like foliar, but I think they're all surviving in the soil, a lot of them. And when I mean, we do about 20 acres of field trials a year, and for Cercospora and early blight potatoes. And where we decide the fields, we test the soil for Alternaria and Cercospora. And you can detect Cercospora in the soil pretty easily. And I've detected powdery mildew in the soil as well. So it's got to survive somewhere. So it's just surviving on the residue, I think. The ground zero for Staphylium is New York, and they grow on the muck soils there. And almost every single fungicide they throw out Staphylium, resistance happens even that year, even with brand new fungicides. And it's because they're growing on continuous muck soils year on year.
Mm-hmm.
And yeah, I think they're crazy, but they won't rotate. Thank you.
Any other question? No?
Yeah.
Let's, okay.
Are there fungicide effectiveness trials that you've done in the past that are available?
For which crop?
For onions specifically?
For me, it's really hard to do Staphylium trials. We've done some with botrytis, and I'm happy to share some of that data and varieties as well if you reach out with me. But with Staphylium, the most important thing is to rotate your active ingredients. They say about frat groups and rotating around that. I mean, I think a lot of growers use Pristine with group 7 and 11. I actually think you could probably go to a Luna, which is another group 7, and you don't have that resistance issue. You don't have to rotate between a frat group because I think it's acting on a different part of that gene. So yeah, just mix it up basically. And that's what we saw with the sugar beets, rotating around those groups. Did a job. Don't get locked into one chemical company.
All right, so thank you so much, James. I guess James is going to come back next year because we've got a lot of questions. So let's thank James again. All right, everybody. So now the next presentation will be delivered by myself. So before that, I just want to say that we are going to share most of the information. I know it's a lot of information for you guys. The recording will be available in my vegetables program website. There will be a QR code in the end. And we also are going to share this QR code in the end. So I just want to say another thing is next week, we are going to share the evaluation for this section. So if you guys could, let us know your thoughts in terms of you like the topics, you want, what are the topics you want for next year? Please let us know, because the topics that we are bringing here today are topics that were surveyed before, or are, growers usually reach out to us and we see a lot of those problems being similar. So then we brought all those presentations today. Okay. All right. So for those who were not here in the beginning. So my name is Milena Oliveira. I'm the Extension Vegetable Specialist here at the Utah State University. So I'm also brand new to this position, started 1 year and a couple months ago. But again, we are new. We want to know your problems, and I like to, start something, just jump into something, right on. So we are going to talk about watermelons, grafted watermelons specifically. We are going to see, what this technique could bring to you guys, in terms of productivity and fruit quality so far. We are also going to dive into the economics further on, but I just want to show some of the results we've got today. So just to introduce the topic, I just want you guys to raise your hands for a few questions, like real world questions. For example, how many of you struggle with cold soils? Like you cannot plant a crop For example, tomatoes, you cannot plant tomatoes before the Memorial Day. Just raise your hand. And I'm included. You know, we have a lot of problems with short season, especially in the northern part of Utah. So second question would be, how many of you lost crops, especially watermelons for, you know, just vine collapsing in the middle of summer, and then you cannot replant because they, you know, it's too late already. And how many of you also had to, you know, replant either in a high tunnel or in the field a crop due to various problems like abiotic and biotic? Me too. So if you answer at least two of those questions, I think grafting could probably help you. There is a couple of things you have to evaluate before that. But basically, grafting is not a fancy technique. It's just about, you know, solving problems, trying to address those kind of issues that happens broadly, not only one issue, but several together. So vegetable grafting is not a new technique. It started in Japan in the 1930s, and then it went to Europe, and then for various parts of the world, especially in Israel. So I spent a couple of years in Israel doing a postdoc, and we grow summer crops during the winter. So we do have a lot of problems with soil-borne diseases, and of course, you know, those crops, they have to survive under certain conditions. So in Israel, I would say 90% of the vegetable crops are grafted. They must be grafted, otherwise they won't survive. So, so then it moved to Europe a couple, you know, years ago later, and in the US is pretty new. Let's say it's relatively new. So the technique is being known for a couple of years, 10 to 15 years. So a group of researchers in the East started to work on grafting, trying to see profitability economics on this topic. And those black dots and yellow ones are publications or fact sheets that you can find on various topics related to vegetable grafting. As you can see, here in Utah, we do not have anything related to vegetable grafting. We are the first ones who are starting something. There are a couple of people that they do by themselves. They try to do by themselves, gardeners, but there's basically no data, like reliable data that can prove that the technique is feasible to the state. So I would say, is the healing chamber. So the healing chamber, it is one of the most important pieces when we talk about manually grafting. So you have to basically make a very nice setup and adjust it according to your conditions. So market prices, for example, early season premium sometimes pays off better than later season prices. And I'm going to show an example. So rootstock choice is also important. Some rootstocks cost more than others. Squash rootstock, it seems, costs less than the Carolina root strong back just because of their benefits. So Carolina has two major benefits, which is fusarium and nematode resistant. It is a fusarium nematode resistant, while the squash hybrid is just a fusarium resistant. Crop and cultivar. So you also have to, select by, similar. For example, some cultivars, they price more than others. So sometimes you can use one variety and, if this rootstock, it is a bit costly, but it pays off. So you find a way to go, okay? And all the way around, right? So usually we have a consensus right now that vegetable grafting, there is an increasing adoption on vegetable grafting. Why? Especially for us here in the West. So we do grow vegetables. We try to grow our vegetables in a semi-arid region. And again, I am coming from a small farms operation in the northeast part of Brazil, pretty much dry. So I know exactly what you guys face, but you guys are harsher, I would say, because you guys get a very short season, while in Brazil, my state, we can grow vegetables year round. So we do have an option, but our heat and solar radiation is so high that basically kills every plant if we don't take care of them. So I know that, I know the challenges that you guys face on living this kind of environment. So the economics take home message is that it is unsettled, so we are studying this technique, and you guys also need to evaluate in your operations to see if it works. But for most of the research and for most of the folks that I have been talking to, and my experience that I'm going to show, it is a very nice technique. Yeah. So, again, there is a concern that there is a current scenarios is that small to large scale operations are increasing, especially organic, so they can get that high premium price earlier, and especially if they are under high tunnels. So this is a very short example. As I said, I'm not an economist, but I like numbers. I really like to see things. So here is an example of a grower growing watermelons, grafted watermelons last year. So I gave this grower some plants, and I asked him to test them. So he did, and the results were pretty nice. So this grower, he has a lot of problems with salinity. He has a lot of problems with soil-borne diseases, also heat in the peak of summer. But he's got from this field where he was testing them, 15 tons per acre of a grafted watermelon onto a squash hybrid. And while this is the non-grafted, 15 tons per acre on the non-grafted, and 31 tons per acre on the grafted, the cultivar onto the squash. So I think it was a pretty good result. He also mentioned, and we do have to take in consideration these early and the late season prices. So early season, 32 cents a pound, and late season, 20 cents a pound. All right. So for early, if we calculate the revenue for these, for grafted plants, you've got almost $20,000 for those 31 tons per acre, while if I wouldn't have grafted, or the non-grafted plants would give him only about $10,000. Okay, so it is pretty good results. And then in the late season, we were asking the question, Does this make sense for the late season? It does. So for the late season grafted plants, revenue was about 12,500, while the non-grafted was 6,000. So for this situation, it did work still in the late season, all right? But you do have to take in consideration that a grafted plant costs 50 cents to $1 more than a non-grafted plant. But in this case, it did even paid off after removing the cost on the plants. I gave away his plant, so I did not show the results anyways, but it did. Now I'm gonna show a few, just two few results on the watermelons rootstocks that we have been working on here in Logan. So when I came to Utah, I started to ask growers about their problems, and I've got this list, you know, and I started to check those boxes to see if I was trying to find a technique that it could solve most of, like, at least two of the problems. So I checked my boxes and I said, we have to try some grafted plants to start with some. Is it watermelon grafting, since I'm working with grafting, worthy for Utah? My answer so far is that yes, but I am also looking to other components to say, you know, for sure, to affirm that for sure it is. For that, we need money, we need students, we need, you know, that's why I bug you guys so much for letters of support sometimes, trying to get some dollars so we could test in many of the counties in Utah. I started testing 3 cultivars, exclamation, fascination, and sentinel, 2 triploids and 1 seeded. I did use the squash hybrid, which is a fusarium resistant, and a Carolina root strong back, which is a fusarium and nematoid resistant. So we grafted those onto the squash Carolina, and I also asked a question if only that wounding, you know, that cutting would make a difference. So I asked the company to do self-grafting for me, which is basically take exclamation, cut it, and then join with an exclamation, just that wounding. I want to know if that wounding would make the plants become stronger. And then we compare with the non-grafted. I did this trial, we did this trial in 2024 and repeated in 2025. My plant spacing was 4 to 6. Grafted plants, you do have to take into account that they can grow even, you know, in large space. I have seen 10 feet apart between rows. We did use 3 plants for the first year and then 4 plants for the second year in terms of plot area. Here, I don't want to go into these more details, but I basically decreased the water 25% because water is a big issue as we have in here. So then I said I have to select one of those challenges. So we started with the water. There is a technique which is the deficit irrigation, which you basically decrease that amount of water in certain periods. And in our case, we decrease the amount of water during the measure crop production part, which was production. So here are the results for 2024, which I have shown already last year, and I want you to see the next year. So, for example, here you have an example for exclamation. So exclamation on is the green one. Exclamation on the green one is onto the squash rootstock. The orange is onto Carolina, which is a wild watermelon. Again, it does not produce. It's just resistant to pathogen disease, soil-borne diseases. The third one was the self-grafted. So it did pretty good, actually, compared to the non-grafted, which is in pink. And here you have the control, which are plants under 100% ET, evapotranspiration. And then this is the drought treatment, which I decreased 25%. So the squash one increased 174% in terms of yield. The second one, Carolina, 64. And the self-grafted did pretty good. It did increase it 51%. in yield. And then we saw similar results under drought. In the second year, which was last year, so again, the squash, now the squash is, this is the fascination, that's why I changed the colors. So this is the fascination, so I just want to bring a new cultivar, but basically the results are similar. It got the same trend. So fascination did pretty well. Onto the squash hybrid, it increased 201%. That's crazy compared to the non-grafted plants. For the Carolina, the wild watermelon under control, it increased 179. And the self-grafting, that wounding part, we are still evaluating that because it did not do well for fascination this year. Okay, so we had for this trial and did similar patterns, as you can see, the production increased pretty much in the drought. So the second year, we think that next year we will probably try something else. So let us know if you wanted me to try with the drought again, maybe decreasing more water, or if you want nitrogen. There is a lot of concerns in terms of nitrogen. I have not evaluated heat stress on those. This is also one thing. So research takes time and effort, and sometimes we have a lot of things to take care, and sometimes we cannot do as much as we can during the summer. So, but yeah, let me know if you are interested to which kind of topics you want me to search. Again, the quality, there was no significant difference in terms of sugars for the 2024 and for 2025, as you can see, for fascination and for exclamation. And yeah, so the take-home messages is please evaluate the strategy, and I'm very happy, to be working with you if you are interested in the technique. This is the QR code for the vegetable grafting website. If you have interest in look for resources, sometimes the USU is very, it's very difficult to find things at the USU website, but you can go to this website, and there is a lot of resources. And yeah, thanks so much. So right now we are gonna head with the last. I don't know if I have time for questions. Do you have any questions? Oh yeah, so I will be sharing my evaluation. If you guys could, extension. So we need numbers. If you could, please fill my evaluation. I'll be very happy. Do you guys have any questions in this topic? Nope. No questions. Okay. Oh. In Idaho, or do you know any growers who are doing anything there? Yeah, happy to connect. Okay, thanks so much. So our last talk will be on soil health, which is pretty important. Katie, is that okay? So Katie, she will introduce herself, but she's in UDAF, and she's gonna share nice, insights into the soil health. Thank you. So you can use it.
Okay, great.
Yeah, thank you.
Thank you so much for having me. Like you said, my name is Katie Ottman. I'm the Ag VIP and the Soil Health Program Manager at the Utah Department of Ag and Food. I don't have a ton of time today, so I just want to give everybody a brief overview of our program and a little bit about soil health. So just to get started, so the Utah Soil Health Partnership, we are a group of collaborating organizations, but our goal is mainly to increase the adoption of soil health practices through incentive-based programs. We're focused on demonstration, education, outreach, research, and different implementation projects throughout the state. We have 11 different partners, so we don't do this alone, but we have a lot of great people who help us out. So what I want to do today is just kind of give a brief overview of the principles of soil health. Has anybody seen some version of this presentation before? Have we heard of the soil? Okay, this is good. So there are 6 of them, and so I'm just going to run through them, talk about them, how we can implement them, and then get into some resources that the state has. So the first one is knowing your context. And really what this means is just understanding what makes your operation unique. So this could be the climate that you're working in, the precipitation that you get, the geology that you have, your soil type, local ecology, what kind of cultural limitations, like are you conventional, organic, non-GMO, things like that. The personal goals that you have on your operation, the equipment that you have available, the list goes on. And this can change just across the fence line between you and your neighbor. And really the reason that we want to keep this in mind is just knowing these things will allow us to make better decisions that will help us be more successful. So that's all I'll say on that one. Second one is keeping the soil covered. I'm pretty sure this is a real billboard that was in Iowa, but there's so many reasons why keeping the soil covered is important. Most importantly, cover, whether it's residue, whether it's cover crops, it acts as a blanket for our soils. And so that helps us to regulate our wind, our water erosion, our evaporation, transpiration, as well as our soil temperature. And at our scale, maybe, you know, this doesn't seem like a big deal, but if you zoom in, I'm gonna, oh, let's see if this will play. Okay. But when you look at it on sort of a soil scale, every raindrop that hits is like a small explosion when you look at it on bare soil. So see if I can get back to this. Okay. So the average raindrop hits bare soil at about 20 miles an hour. And so like you saw, that is like a small explosion when you look at it at that small scale. And why this really matters is because when you have raindrops hitting bare soil, you are breaking apart those soil aggregates. And when that happens, you form surface crusts. So as those aggregates break apart, those individual sand, silt, and clay particles, they settle back on the soil surface. They don't settle back in these nicely formed aggregates. They just sort of disperse over the soil surface. You fill in all of the gaps and the pores in the soil, which reduces infiltration, increases your runoff and your loss of any inputs that you might have just put on your soil, and also increases anaerobic conditions. And we've talked a lot today about different diseases. Disease loves anaerobic conditions. So you're not setting yourself up in a good position when you have crusting in bare soil. I also mentioned soil temperature. So I love this example. So this was taken in one place, just on two different fields that were right next to each other. You can see in the middle, it was only 56 degrees outside. So honestly, kind of like today. When you shot just a surface thermometer at a field that had some cover on it, we can see the soil temperature was significantly warmer than the air, about 90 degrees, but significantly lower than the bare soil on the field right next to it. On a 56-degree day, that soil was almost 107 degrees, which is crazy. And why this matters is this chart on the right. So soil microbes, much like myself, have certain temperatures that they like and don't like. So 70 degrees, I'm super happy. It's great. The sun is shining. 100% of that moisture in our soils is used for plant growth. Once you hit close to 90 degrees, 85% of that moisture is going to be lost through evaporation and transpiration, and plant growth slows significantly. Once we reach about 110, 113, our bacteria species start dying. These are really important for things like nutrient cycling, aggregate stability. Once you hit 130, you're losing 100% of your moisture. And that's really important because it's not going to take that long to get here. This is on a 56-degree day. If you think on a summer day, it's significantly warmer than that. Those soil temperatures are going to creep up really fast. So minimizing disturbance. Disturbance can be a couple of different things. So it can be physical disturbance, which is what we typically think of. So this could be tillage. It could be overgrazing if you're in a grazing system, probably not very applicable to people here. It can also be chemical disturbance. So whenever we apply pesticides, fertilizers, things like that, these are all forms of disturbance that are going to disturb our soil microbiome, as well as our aggregate stability. As far as physical disturbance like tillage, the biggest thing that we see with this is a loss of soil structure, and all the things that I already talked about with decreasing our infiltration rate, our water holding capacity. We have compaction buildup in our soils. We lose our organic matter. We get soil crusting, decreased water availability. We lose sort of our nutrient cycling and retention. And we lose that soil habitat for our good biology that we really need to fight disease. And so you can kind of see this progression over time. with the increased crusting, the compaction, it's just not great news. Another way to look at this is to picture sort of the ideal soil, and we have typically 50% organic matter, mineral matter, and then another 50% is air and water. When we start losing those pores in our soil, when we start destroying those aggregates, you can see how that gets skewed, and we lose a lot of our air and moisture, our ability to transfer those in and out of the soil. Another thing that we get with compaction, we see a lot of effects on the plants. So this was an alfalfa plant. You can see on the right, this is a great healthy soil. That taproot is growing straight down. On the left, this was a super compacted field. That taproot didn't even go down an inch before it took a hard right and did a 90-degree turn and was growing sideways. So definite limitations on our plant's ability to get water, to get nutrients, things like that. Number 4 is maximizing biodiversity. And so I love this diagram. I think it's a really great example of why this matters. So every plant family we kind of like to think of as a different tool in our toolbox. They have different root architectures. They have the ability to scavenge different nutrients, deter different pests, and attract different soil biology. And so when we have a monoculture, we are not fostering these different things. And so being able to get these into your rotation, whether it's through your different cash crops or through a cover crop, can really help with a lot of these things that we've talked about today, like disease and pests. You can also look at restructuring your crop rotation to make the best use of those nutrients as you cycle through your different crops, following really nitrogen-hungry crops after things like legumes. And we talk about different families. This is kind of how we think about it. So we have our warm season, our cool season. We have our grasses, our broadleaves, and within that, we think about legumes and brassicas kind of differently as well. So the more of those different combinations that you can get, so like warm season grass, cool season grass, into your rotation, the more tools you're putting in your toolbox. There are so many resources out there for how to do this. With cover crops, there's a ton of different websites. This is a screenshot from the Green Cover website. They have a smart mix option, so you can go in, you can say what your goals were. So in this one, we had weed suppression, compaction, breaking, increasing soil organic matter. It'll take into account where you are, your crop rotation. It'll make some different suggestions for you. So if you can put a cover crop in there, that's really great for, like I said, weed control, soil erosion, maybe attracting some pollinators, some beneficial habitat, nutrient cycling, and just adding some overall biodiversity. So that goes right into keeping a living root. The reason this is so important is roots build soil structure. So plant roots exude these sticky sort of sugar-filled exudates. And these glues are what glue those soil particles back together. So the more that we can keep a living root, the more we can harvest that sunshine, turn it into sugar, and rebuild some of our soils, and also feed our microbes that are critical for things, like I said, like nutrient cycling, things like that. Cover crops is a great way to do that, especially in the off season if you're done with your cash crops. I've seen a lot of people have success with that. Finally, integrating livestock. I know I'm talking to a bunch of vegetable growers. Livestock probably isn't your thing, but there's still some ways to reap the benefits of that. Incorporating livestock can really help break down residue, help balance your carbon and nitrogen ratios, help cycle nutrients, introduce different soil biology. People who have livestock on their land have different groups of soil microbiology that you don't find on fields that don't have livestock on them, which is kind of interesting. If you have some grasses, it can also help stimulate root exudates and biology with grazing. Go back one. You don't necessarily have to have your own livestock to incorporate and get these benefits. Some of the best livestock are your neighbor's livestock that you don't have to manage. Some people can have really good luck putting a cover crop down after their cash crop and then having their neighbors come in and graze it. Or you could just look into things like compost, other organic amendments, and get some of those benefits that way. So I just want to talk a little bit about some of the resources that we have to offer at the Department of Ag and Food and the Soil Health Program. First and foremost, we love doing education. So we have different conferences, field days, and workshops that go on throughout the year. I'll tell you where to find those. We also have soil health equipment that's available to rent through the conservation districts that we partner with. We offer free in-field soil health checkups and technical assistance. So if this is something that's interesting to you, you want to have a planner come out and talk about how it might be relevant to your operation, we can definitely do that. They can set you up with a plan specific to your operation. This just happened, but we have our biennial Soil Health in the West conference. So that's in St. George every other February. But great time to connect with other people interested in soil health. And then we have our Ag VIP program. If you take one thing away from this, please visit our website, utahsoilhealth.org. It's where you can find links to everything else. We do have an events tab where you can see all the upcoming events near you. It's a great place to find equipment rentals. We have a new dashboard coming that'll be up in the next couple of weeks. So you can type in your address. I think I have a screenshot of it. So yeah, you can type in your address and you can see all the different types of soil health equipment available to you. So we have a lot of no-till drills. I think almost every conservation district in the state has one now. Trying to think what else. Interseeders, some ATV equipment. Really depends on the area, but we do have a lot out there. We can do some soil health checkup. So this is not necessarily nutrient testing or lab testing, but it is a series of things like infiltration rate tests, compaction testing, and a lot of it is super simple. You don't need any specialized equipment, but one of our planners can come out, do an initial assessment for you, and then also teach you how to do it yourself. And this is something that's really great to do year over year, just to kind of get a general sense of what direction you're going. Are you improving your soil health? Is there something we need to change? So this is a great option as well. Like I said, we just had our 2026 Soil Health in the West conference. The next one's coming in 2028. I don't have dates yet, but when I do, I will put them on the website. And then I just want to take a couple of minutes to talk about the Ag VIP program. So our goal is to help producers voluntarily implement these different practices. So nutrient management, soil health, integrated pest management, things like that, to increase conservation and help you meet your own goals. In a nutshell, it's great for producers who are like, hey, I'm really interested in this. I'm not exactly sure what my next step should be. You're looking for some guidance. This is where we come in. Like I said, it's completely voluntary, it's incentive-based, and we really try to make it self-directed. As of, let's see, last year we had over 150,000 acres enrolled in the program, so we've had very good response from producers. But we'll have a trained conservation planner who will come out, they'll do a site visit, walk you through a conservation assessment, and then help kind of identify some of your goals on your operation. And really the process is the same for everybody. How you choose to operate, whether you're vegetable, you're a beef producer, organic, whatever it is, it doesn't change the principles that we're looking to implement. It just maybe how we choose to get there and what practices we choose that'll work best for you. So the conservation assessment, it's just to establish a baseline level of your conservation going into the program. Takes less than 30 minutes to complete. We look at all aspects of your management, and it's really set up well for dryland, irrigated, all kinds of operations. We look at nutrient management, soil health, irrigation water management, pest management, and we kind of try to quantify that outcome. And, everything from people who are just learning about these things in conservation to somebody who's on the far end of the spectrum has implemented every conservation practice imaginable. And so what you get out of this is sort of an understanding of what you're doing well, the ability to explore new practices, get a customized set of conservation plans that can include a nutrient management plan, soil health plan, pest irrigation management, ongoing technical support. We give monetary incentives on a tiered scale based on how much conservation you're implementing, and then some regulatory incentives that are offered through the Division of Water Quality. So helps protect you from any notices of violation or fines if you have a discharge of nutrients or anything else from your operation. So this program is, like I said, looking for people who are, looking to take the next step with their operation, managing cropland, irrigated or dryland, or irrigated pasture. We don't have a size minimum or maximum. You just have to have management control, whether that's leasing the land, owning it, You have to be operating in Utah and willing to try at least one new practice. Our next application period is going to open this spring. We don't have exact dates, probably April or May, but if you go to our website, join our newsletter, you can get alerted as soon as that opens. So happy to take any questions. If not, thank you guys for having me. You guys have any quick questions? Okay, awesome.
No,
thank you guys.
I'm sure you guys are so tired. So I understand it's a lot of information. That's why we record, so you guys can go back and, you know, review that presentation you guys want to see. So do you have any vendors who wants to announce anything, or anyone else wants to say anything before we end? Mike, are you gonna do the raffle?
Just a couple of quick things here.
Okay.
If you're coming for CPU credits and that, make sure your name gets on the blue one. And right next to that, I'll put out your certificates, so that we put them in files and that, do not lose those. Get up on our email lists, sign and read them, okay? So those two things right there.
Mm-hmm.
I'll put it up here in front.
So I'm gonna choose. Okay. Are you gonna do it? No? Gonna do. Okay, thank you guys. Thank you so much for coming. So we're gonna send you guys, my evaluation, Andrea and Maggie, you could give that to her, the evaluation. Yeah, so we are gonna send you guys evaluation for this year. So please let us know what you liked, what you don't like, you know, you did not like, what you wanna, you know, have next year. And please reach out, you know, if you have any other questions. I do work not only with grafting, we do have been working with a lot of other stuff. Cover crops, we do work with a lot of biostimulants. I do test a lot of products. And if you guys have any, you know, any questions regarding vegetable production here, I'm trying to still learn with you guys, you know, in the daily basis. So I'm very happy to visit you guys, you know, in your farm if you are available. Thanks so much. Thank you.